Now the equation px square equal to ln x should have exactly one solution. Then the domain of P is required. Now if you look at, there are two curves in this graph, in this equation that is given. What are they? One is y equal to px square and another one is y equal to ln x. Now the graph of y equal to px square would change according to the values of p. So there are two possibilities arises here. Let's consider the first possibility as p is less than or equal to 0. When p is less than or equal to 0, can you identify how will be the graph of y equal to px square? Yes, it's a parabola which is open downwards. This is the graph of y equal to px square where p value is less than 0. Now how will be the graph of the second function y equal to ln x? Up to 1 the functional values are negative, and after 1 the graph will be in the positive quadrant. That means it would start at infinity and at 1 it crosses x-axis and enters the first quadrant. So this is the graph of y equal to ln x. Now clearly whenever p is less than 0, the graph would obviously possess only one point of intersection. The graphs of y equal to px square and y equal to ln x will possess only one point of intersection when p is negative. So what do we conclude? When p is negative, that is when p belongs to minus infinity to 0, the graphs of y equal to px square and y equal to ln x will have only one point of intersection. When they have only one point of intersection, can we rewrite this statement as p times x square equal to ln x has only one solution when p is from minus infinity to 0. Now what is the second case? Now this is the more interesting case. The second case, when we consider p to be greater than 0. When p is greater than 0, then the first graph is a parabola which is open upwards. Now this will be the graph of y equal to px square when p is greater than 0. Now what can you say about the graph of y equal to ln x when it has only one solution, one point of intersection with this? As the number of point of intersection should be only 1, the graph of ln x should be only touching this is graph of y equal to ln x, then they should be touching at one point, right? Otherwise what happens? If they intersect, they'll intersect at least 2 points. They cannot intersect at one single point. That means it will have two number of solutions. But in order to have only one solution, it's only possible for the two graphs to touch at one point. So what did we conclude when p is greater than 0? One important observation what we observed is y equal to px square and y equal to ln x should be touching each other, right? Let's call this point for a convenience as point P having coordinates x1, y1. Now when do we say two graphs are touching each other? Two graphs will be touching each other only provided the slope of tangent at point P of y equal to px square. This slope must be same as the slope of tangent at the same point P of the second curve y equal to ln x. That means there should be a common tangent at that point, then only the two graphs will be touching each other. Now what is slope of tangent to the first curve at the point P, which is assumed to be x1, y1? This is 2p x1. This should be equal to, what is slope of ln x at the point P x1, y1? Yes, it is 1 by x1. So this is possible only provided x1 square is 1 by 2p. Let's call this as an equation 1. Now we got a relation for x1 in terms of p. As the point P, which is assumed to be x1, y1, is on y equal to px square. When will this point be lying on the curve? Provided y1 is p times x1 square. But just now we got the value of x1 square. This is p times 1 by 2p, that is half. Now y1 coordinate is 1 by 2. Now the same point P x1 half, because we know the y1 value now, half is on the second curve which is y equal to ln x. When is this possible? Provided half equal to ln x1. So can you tell me what is x1 value? Yes, the value of x1 would be e to the power of half. Once we have the value of x1, can we identify the value of p from here? So then again in this case, from the equation 1, when we calculate the possible value of p so that there will be only one point of contact, p becomes 1 by 2 x1 square, that is 1 by 2 times e to the power of half whole square, which is 1 by 2e. So p is positive, there is only one possible value of p, that is 1 by 2e. But when p is negative, what we observe? Throughout from minus infinity to 0, there will be only one point of intersection and hence only one solution. So what is the total combined solutions of p so that you have only one solution? Yes, from minus infinity to 0, all negative values of p, and in positive values only p being 1 by 2e. So which option is satisfying? The option presented B is satisfying the required equation having only one solution.